Addressing the emissions of hard-to-abate sectors will be a critical step to meeting decarbonization goals. Heavy industries such as cement, steel, and chemical manufacturing account for around 30% of global emissions. Carbon capture, utilization, and storage, and direct air capture provides opportunities to decarbonize these industries at scale. Policy solutions, novel technologies, and industry partnerships can help facilitate the abatement of heavy industry emissions. Here to moderate our panel on hard-to-abate emissions is Senior Carbon Capture Policy Manager at the Clean Air Task Force, Angela Seligman.
Thank you, Abby. Great. Oh, okay. Get nice and close here. Well, thank you so much, Abby. And I'm really excited to talk with all of you today about hard-to-abate industries and moderating this really great panel that we have today. I'm going to kick this off with a quick overview presentation on a report that Clean Air Task Force put out at the end of last year that focuses on these hard-to-abate sectors, but looks specifically at what happens to the criteria air pollutants when you install carbon capture and sequestration on a couple of these hard-to-abate sectors. So to start off, we'll dive into this report, and I'm going to go through this as quickly as I can to not take up this whole panel time. So it'll be a little bit of a whirlwind tour of what we looked at in this report. So this report was a desk analysis that modeled the potential impacts of installing carbon capture on 2 different sectors, so 4 facilities. We looked at using an amine-based scrubber system that was installed on 2 fluidized catalytic cracking units at 2 petrochemical refineries, and then 2 cement manufacturing plants. 2 of these are in California and 2 are in Texas, which are shown in the map on the screen here. Specifically, we looked at petroleum refining and cement production because, as Abby was just pointing out, these are among the top 5 categories of industrial greenhouse gas emissions. And we also looked at these because these can also be large emitters of conventional air pollutants, and this is specifically what we wanted to look at here. The other thing to note about the 4 facilities that we chose is that we were looking at high emitters in these sectors, and this is why we chose these 4 facilities. And one really important thing that I also want to point out here is that with this analysis, we were specifically looking at what we would need to do to these criteria air pollutants at the facility to be able to install reliably and effectively a carbon capture system using that amine solvent. And so we weren't looking at how much we could reduce these air pollutants, but what we would need to do to reliably install carbon capture on these facilities. So diving in first, on we'll say the easiest one, we were installing carbon capture, and so goal number 1 is reducing those CO2 emissions at our facilities. We looked specifically at a capture rate of 90% at each facility, but really importantly, we also took into account the increase in emissions associated with the energy needed to actually operate that capture unit. So this ended up with a modeling exercise of looking at an 87% reduction in CO2 at each of these facilities. And in total, if carbon capture were installed on these 4 facilities, it would reduce CO2 emissions by over 5 million tons per year. So that's just looking at the start here, how much of the CO2 from this modeling exercise we would reduce. But then let's dive into what we would need to do in terms of our criteria air pollutant reductions to be able to reliably operate this capture equipment. So starting with particulate matter reduction, we would need to reduce the particulate matter at each of these facilities by greater than 90%, which if this were installed on these facilities, we would get a reduction of nearly 1,000 tons per year of particulate matter between these 4 facilities. The nitrogen oxides are a little bit more complicated. Again, we're looking at what is needed to be reduced to operate the equipment. And so one important thing to note is this is looking at nitrogen oxides as a whole, but not all of those species of NOx interact negatively with the amine solvent. And so you don't need to reduce as much, depending on what types of species of nitrogen oxides, you don't necessarily need to reduce as much of your nitrogen oxide emissions. This can also be dependent on what types of pollution control you currently have on your facility, and then what types of pollution controls are also available to further reduce those pollutants. But even taking this into account, we still see over a 500 ton per year reduction that we would need to have if carbon capture were installed on all 4 of these facilities. The most exciting and impressive one that we saw is the requirement to reduce your sulfur dioxide emissions. And at each of these facilities, we saw greater than a 99% reduction in sulfur dioxide emissions, totaling over 3,000 tons per year, combined from all of these facilities. One other thing, I don't have a separate slide to show this because I was trying to get myself to move quickly through this presentation, but an important thing to note additionally is that we also looked at the changes in volatile organic compounds at each of these facilities that is associated with the amine solvent that's used to capture the CO2 from the facilities. And we're seeing great emission reductions from our criteria air pollutants, but we do also see an increase of about 2 to 3 tons per year of volatile organic compounds from each of these facilities. And for the last slide that I have here, using what we saw from this modeling exercise of our reductions in sulfur dioxide, nitrogen oxides, and particulate matter, and still taking into account that increase in volatile organic compounds, we used EPA's co-benefit tool to get a sense of how this would impact local public health. And the big note here, and this is looking at the high end, of course, of what we could have in terms of reduced annual mortality, but we're seeing that if you were to install carbon capture on all 4 of these facilities, you could save up to 85 lives each year based on that net reduction that we're seeing in criteria air pollutants. We see the largest improvement in public health associated with installation of carbon capture at the Martinez refinery in California. This is because that is one of the dirtier facilities that we looked at, and it's close to multiple large population centers. And so to end with this initial frame-setting presentation here, what we're seeing is that carbon capture, of course, its primary use is to reduce CO2 emissions from facilities as a decarbonization tool, but we can also look at it from a win-win perspective of slowing climate change and improving local air quality and saving lives. And so with that, I'm excited to move on through our panel presentations today, and I'll pass it over to Melissa.
Great, thank you very much. Hi, everybody. Just get my tools organized here. I am Melissa Carey. I'm the head of climate, ESG policy, and government affairs at Holcim US. Thank you very, very much for the opportunity to speak with you today about our plans to decarbonize our part of our industry, which is building materials. And for the purposes of decarbonizing, I'm definitely going to highlight our cement and concrete production. This is an industry that is really worth your focus and your attention. If you don't know this already, and you probably don't, cement is the most transacted material in the world after water. It is globally responsible for 8% of emissions. And with the world projected to build the equivalent of a New York City every month for the next 40 years, it is essential that we build smarter, we build cleaner, and that we do so with an eye toward reducing our climate impact. So thank you very much to WGA, and really looking forward to the discussion. Let me move through this in tandem. Let me give you a word about us to start in case you're not familiar with Holcim. We have close to 350 sites in 43 states. We employ more than 7,000 people in our cement, concrete, asphalt, and aggregate production. We also are proud to have Holcim Building Envelope as part of our U.S. presence. Building Envelope covers roofing, insulation, sealants, and all the things that you might imagine that would make a building envelope energy efficient. We are the largest cement producer in the U.S. We have 13 integrated cement plants, 2 grinding facilities, 98 aggregate, and 121 ready-mix sites. We also have more than 100 terminals all across the United States, so we're a large presence. We are also very unusual in our industry in that we have a net zero by 2050 commitment that is transparent and verified by the Science Based Targets Initiative. We are wholly committed to decarbonizing our operations on that time frame, and I'm going to walk you through a little bit of what that looks like for us. Okay. So, in short, we're on a mission to decarbonize building across its entire life cycle, to build a net zero future that works for people and the planet. So this graphic is from our 2023 climate report, which you can find on our website. And what you'll see is that as we look out to 2050, we have to look at our carbon emissions on a number of fronts. I don't know if you can read this from where you all sit, but this graphic covers everything from carbon capture, use, and storage. That's that big blue bar at the bottom. But also all the other strategies that we need to employ, like clinker substitution, alternative fuels, reusing recycled content, and other strategies that we can employ now, even as we're getting a lot closer to commercial deployment of carbon capture and storage in the US. But before I get to kind of the individual components of this, I wanted to draw your attention to the time aspect. We view ourselves as being on the clock to decarbonize. I think everyone here knows this, but I'll just repeat it. This is not a challenge like other environmental challenges that remain kind of static while we work on solutions. Every year that we delay in doing all that we can to reduce carbon is a year in which we exponentially increase the damages and risks to all of us from a warming climate. So we take the time element of this very, very seriously, and that's why you'll see when you look at this chart that we are working, of course, to get to full-scale carbon capture and storage on our facilities, but we're not waiting on that. We're also working on materials substitution, on renewable energy, on electrifying our fleet, and so forth. So let me show you what that looks like. So this is another graphic from our climate report, but it really breaks down the opportunity set that we have before us. So this graphic shows our Scope 1 emissions, our direct emissions, starting with the electricity that we use to power our operations and going straight through the production process to our end product. And what you can see here is that we are making use of all the strategies that are available to us. So alternative fuels, last year we diverted more than 1.7 million tons of byproducts and landfill material, or landfill destined material, into our kilns and to our processes. So part of our goal is to increase thermal substitution to 50% by 2030 and 70% or more by 2050. We are also looking at using alternative raw materials, whether those are natural materials like calcined clay or pozzolans, or some waste materials like slag and fly ash, which are other things that we can incorporate into our products to substitute for the carbon-intensive clinker that we make. We are also moving to renewable energy. In our facilities, we're doing a mix of on-site generation and purchased renewable power. But the pledge that we are well on the way to fulfilling is to have 100% of our energy needs come from renewables by 2030. And then, of course, all of this brings us toward 2030 and beyond, where we anticipate carbon capture, use, and storage is the largest part of what we're doing to keep our carbon out of the atmosphere. So I'm going to leave it here and look forward to your questions. But I did want to just encourage you to think both big and small when you think about building materials and climate. We are known as a hard-to-abate sector, and there are some things about our sector that are really, really hard. Process emissions are really, really hard. They're inherent to the manufacture of our basic products. But there are also a lot of things that we can do now while we're working on the really, really hard part of this to get our carbon emissions headed in the direction in which we need them to go. So by building smarter, by having cleaner manufacturing processes, by reusing materials, and just by thinking systemically about what we choose to build, we really feel like there is every opportunity for our company to work with all of you to build a net zero future for our sector. Thank you. I'm not in charge of that part.
Well, thank you so much, Melissa. Tom, I'll hand it over to you for your introduction.
Hi, everyone. So my name is Thomas Price. I'm here representing the Industrial Efficiency and Decarbonization Office. I'm an energy analyst and contractor working with energetics, but I spend all my time at IEDO, and I'll be referred to IEDO. I also work within the sphere of the federal government, so if I start speaking in acronyms, call me out, please. It happens all the time. But I'm really happy to be here. And yeah, I just kind of wanted to start with something that's already been said, but really what we're looking at right now is 30% of our energy-related emissions really comes from the industrial sector. And so this includes, hard-to-abate sectors. It also includes manufacturing, agriculture, mining, and construction. My office and what I specifically work for in terms of our portfolio is really settled in that manufacturing space. And so we're not looking at manufacturing, or we're looking at manufacturing, we're not looking at agriculture and mining. We have kind of sister agencies at DOE that do that. But my biggest plug, and something that we need to kind of realize, is there is still growth. We can apply CCUS, but there's still growth within these manufacturing spaces. And sometimes that growth is enough to really kind of limit the amount of CCUS that can impact the actual carbon management of the space. I did want to kind of just lay out kind of how IEDO is kind of looking at our space and using our funding. We kind of have couple aspects within our portfolio. And the first one, where I work more specifically, is the energy and emission-intensive industries. So that's iron and steel, chemicals, food and beverage, forest products, cement and concrete. Absolutely a sector-specific approach, and we really truly believe and understand the complexity that there is here in manufacturing and the industrial sector. There are very specific solutions based on industry itself. We also totally understand that there are cross-sectoral opportunities, and the biggest one is thermal processes and systems. These CO2 emissions from industry, about 60% comes from process heating alone, and so this is a really big area. We also have low carbon fuels, feedstocks, and energy sources, emerging efficiency, and of course, water and wastewater treatment, which is another place I spend a little bit of my time. The last piece, and I think this is a really important piece, and I wish I was connected a little bit more into it, but this is the technical assistance and workforce development that was mentioned last session. And I think it's really important to understand that this is a new space and there's opportunity here. And while people are really, interested in, becoming more sustainable, some people don't even know where to start. Some people haven't even started, and that's a reality that we're really hoping to acknowledge. Kind of want to do kind of a shameless plug. Please subscribe to our newsletter. This is where you're going to find announcements, funding opportunities. Also, we have a huge portfolio, not only in carbon capture and utilization, but everywhere else in terms of decarbonization. So please check out our project database. Last little shameless plug is we did announce a funding opportunity announcement last week. It's focused on hard-to-abate industry, so chemicals, iron and steel, cement, food and beverage, and concept papers are due March 19th. So again, everyone out here, I charge you to please submit and make a difference here. I'll now pass it off.
All right. Well, I had a chance to talk to Thomas before this, and the most impressive thing that I heard was all of his technical expertise, which is very, very impressive, but he actually lives in Telluride and is here despite a massive snowstorm in Telluride. So we should all give him a round of applause for that. My name's Cully Cavness. I'm a co-founder, president, and chief operating officer of Crusoe Energy Systems. So we're a Denver-based company that we started with capturing flaring natural gas and using that otherwise wasted energy to power modular data centers. And since then, we've expanded into some other types of energy sources. I'll give you a little bit of background on where we came from and what our company does. But I think the reason why I was asked to be on this panel is that maybe this is an example of something that used to be viewed as hard to abate, which is sort of peripheral flaring around the margins of oil fields. And these are sort of small volumes, relatively speaking, and they don't last forever. They're sort of a point-in-time problem where flaring might exist for a few years and then decline over time. So for a long time, it was not clear how are you going to economically gather these and manage this otherwise wasted gas stream. And our approach has, we think we've kind of broken through that and proven a new model where it is economic to do this, and there's a lot of environmental benefit to doing this. So I'll show you some photos of kind of how it looks and what that might mean. So just really quickly, globally we flare about 5 trillion cubic feet per year of gas. That's it's enough gas to power all of Africa. If you could capture it and use it for electricity, it would be about 2/3 of Europe's electricity demand. And the data center industry on the other side is really rapidly becoming one of the largest and will eventually become the largest single sort of load on the electrical grid in terms of appetite for electricity. And so we view both of these as problems, but also as opportunities. There are sort of climate challenges in the sense that that's a lot of wasted energy and emissions with no beneficial use on the left side there, and that's a lot of incremental load that, if it's not sourced properly, is going to contribute to a lot more emissions as well. Again, if you captured all that gas, it would power 2/3 of all of Europe's electricity. Data centers are already on track to consume 8% of the world's electricity. And this is actually old data. With AI coming out and some new research, it's actually, most of the new reports are saying we're going to pass 10% within this decade. And computing will consume double-digit percentages of the world's electricity within the decade and thereafter. An interesting comment that isn't always appreciated about flaring is that flares don't fully combust methane. And recent studies have indicated that maybe 9% of the methane escapes from a flare. And methane is such a potent greenhouse gas. We were actually talking about this before the panel. It's 82 times as potent as CO2. So that small percentage that escapes is actually responsible for 3/4 of the total greenhouse impact of the flare. It's the methane escaping, even as a small percentage, it's 3 times more potent than all the rest of the methane that gets combusted into CO2 because of the 82x global warming potential factor that's associated with methane. So getting rid of a little bit of methane goes a really long way. It's one of these low-hanging fruit, which is, in this case, it's really true. It's environmentally and economically the low-hanging fruit. And just some really quick numbers on data centers. So this is a chart that comes from McKinsey & Company, a recent study. What it's basically showing is that the amount of power consumed by American data centers is about 15 gigawatts today and expected to rise past 30 to 35 gigawatts by the end of this decade. And this is actually a more conservative projection than others. Boston Consulting Group has it going to 45 gigawatts, and this is really being driven by artificial intelligence. So AI powered by graphics processing unit clusters. They're very energy-intensive computers, and there's just all of a sudden, with ChatGPT coming out and so much investment going in the space, there is an absolutely historic boom in data center construction activity, and all the existing data center space has really been taken up and is being converted to this much more energy-intensive kind of computing. So again, where and how we source that power is going to matter a lot vis-a-vis any climate goals. Also, the dark blue bar, those are the hyperscalers. So that's Amazon, Microsoft, Google. The light blue bar is what you could think of as independent data center operators. That's really where Crusoe would operate. And then the gray is enterprises, so large companies operating their own data centers. And you can see that kind of the biggest categories and the fastest growing is this independent data center space where there is an opportunity to sort of do it a different way. And so that's where Crusoe came from, is recognizing that maybe one problem can solve the other. Maybe the very large appetite for electricity from the computing sector could be a solution to soak up some otherwise stranded and curtailed energy, both in terms of flaring, and increasingly there is unfortunately a growing problem of curtailed renewable power from aging wind farms that don't get the production tax credit anymore. And when prices go below zero, they have to curtail. And so we started actually with Bitcoin mining. This is my co-founder and I. We grew up here in Denver together, went to high school together. He's sort of the technical co-founder. He was a math and physics major at MIT and then studied computer science with a focus in AI at Stanford. I'm a geologist and went through an MBA program and has been more on the finance and business side of energy, working in geothermal energy, on the renewable side, and then later in oil and gas. So I've kind of been on both sides of the energy transition there. And we started with Bitcoin mining and then have really increasingly transitioned to GPU computing for AI. And today it's about 30 to 40% of our revenue comes from the AI piece. And it'll be more than half of our revenue sometime this year as we really focus the budget on that. This is really how it looks. So it's hard to see in this photo, but in the background, you'll see an oil field operation, those tanks. And on the left side of the tanks, there are two flare stacks, and there's no fireball over those flare stacks. They're actually not flaring gas. They would otherwise be flaring gas. But we've installed in the foreground this is a 36 megawatt power generation production and data center consumption co-located all at one site in the oil field. So the sort of bigger boxes on the far right are generators. So that row, you see 5 of the bigger structures. Those are 5 2-megawatt generators. And then they're each connected to 2 1-megawatt data centers, which is the smaller thing that looks like it might be about the footprint of a shipping container. On the left side is actually a gas turbine. So we have two models. We do a 2 megawatt building block, which you see on the right, and we do a 16 megawatt turbine-based building block for larger sites that'll be there for longer. And putting all that together, we're preventing about 8 million cubic feet of gas from being flared that was previously being flared. 5 million cubic feet in this example. It's scalable to 8, and it's producing 36 megawatts of power and computation from a energy source that was already basically being produced and wasted. And in the process, reducing a lot of methane emissions. Our generators get 99.9% combustion of the methane, which, again, relative to letting 9% escape is a really big reduction in the CO2 equivalent. We reduce the CO2 equivalent by about 67% compared to if you continued flaring. This is another project. This one's in Montana. So this is 2 million cubic feet per day. It's a modular system, and we will remove modules as the wells decline. And then we have a business development team anticipating that with some reservoir engineering to know when the wells will decline, and they're looking ahead and contracting for new projects so we can remobilize. This is what one of the artificial intelligence data centers look like. This is actually a data center in an oil field. So it's a clean room environment on the inside. If you were to step out that back door, it's actually literally in an oil field. There's oil tanks and flare stacks right there. And this is AI model training data center. So it's a type of, it's either inference or training. And training is quite energy intensive up front, and then inference is using the model long term. This is a training data center. So somebody's able to, through a fiber connection that we built out into rural Montana, train an AI model in a data center powered by gas that was being flared previously, and reduce methane emissions in the process. And actually at a lower cost than if you were to use a hyperscaler, because we're using this wasted energy stream, so there's a cost advantage there. So it's, again, 99% reduction in methane emissions compared to flaring. It's about a 69% reduction in CO2 equivalent emissions compared to flaring. Also, on the criteria emissions, we're getting some really big reductions, 99% reduction in VOCs, for example, 95% in carbon monoxide. So these are more human health-oriented emissions factors. And I would just like to say it's really privileged to represent a team that does all the hard work. I don't know how to build and operate an aeroderivative gas turbine like you see in the background there, but our team does, and our team knows how to do a lot of really amazing technical and commercial things. And so it's really been a privilege. We've got 325 employees now. We've raised a little bit over $1 billion, and we're sort of a large-scale provider of AI computing and Bitcoin mining, and we're doing it in a way that where we try to source our energy from climate-aligned sources, mostly by preventing waste. So that's the end of my slide deck there.
Well, thank you so much, Cully, and thank you everyone on the panel here. We will dive into some questions. Staying with the hard portion of the hard-to-abate theme of this panel, I wanted to touch on if you all see any foreseeable challenges or limitations in the widespread deployment of CCUS technologies within these hard-to-abate industries, and what strategies we can employ to overcome these obstacles. Some things that always come first to my mind living in the Midwest are around the CO2 pipelines that we seem to be having a lot of trouble building out, as well as not every first project looking like a complete success every time. But I'd love to open that up for a discussion in our panel here.
Sure. I'll add to that. I think about this really as like enabling conditions, right? It's not that we don't know how to do this, but it's a big undertaking, and there's a lot of infrastructure that goes along with it, right? Not just installing the technologies that are needed on different manufacturing processes, but also there's the capture part, right? And then there's the transport part and the storage part. And all of these components have been done, right? They exist somewhere in the world. They've all been done numerous times over. But putting together an integrated system and siting it in the US in a real place on the ground with community engagement and buy-in is a different thing. And so in the previous panel, we talked a little bit about community engagement, and I do think that's a really underplayed, discussed aspect of this. I was listening to the panelists before us talk about kind of how information gets passed around, and whether it's true or not true, and I think one of the big hurdles that we have is having a sort of a fact-based and honest discussion about what the technology is, how it gets deployed, what it means or doesn't mean for communities that are involved in it, and also what the value proposition is for the atmosphere. And so there are many different components of that I think are under vigorous debate. And there are a lot of different points of view, and it is my observation that the more information we can have and the better dialogue that we can have about what it takes to make these systems reality, the quicker we will get there.
Yeah, I think that's really important, and the idea of just kind of bringing people together. And I think this is a really tough question for me as a technical person that sits in the chemical space all the time is, how do I make broad statements on barriers? And so I kind of thought of a couple, and you mentioned a couple that I have on my list, but some of those barriers that I have are within the tough to address kind of industries. We understand it's a very capital rich space, right? All the infrastructure that's there lasts for a very long time. And so to get people to, one, try to, add something that wasn't originally there, that can be really tough. But to even get rid of the entire process itself can be very difficult. And so this is, like you said, how do we, make sure that this is something that people want to do? Integration issues are huge, and this is for, carbon capture, but in IEDO, we work a lot with carbon utilization. So let's say you want to create, ethylene from CO2. All of a sudden, you're getting rid of this huge, industry that's not only producing ethylene, but you're reducing the amount of propylene produced and all these other things. And so the integration issue is huge. And I think a big piece for cement as well, and chemicals and anything that's a product, is like product quality and standards, right? And so we need to be able to produce the same products and to make these things still profitable with different feedstocks, with different processes, with decarbonization in mind. And I think that really gets into the idea of strategies. And I think one of those strategies really truly is the idea of co-benefits, or the idea of co-optimization. This is an opportunity. So a lot of the times I think, people that have been running a steam cracker for the last 30 years are like, I absolutely do not want to change to electric heating because what am I going to do with my stranded gas? But I think in many ways, it's an opportunity to address, criteria air pollutants. It's an opportunity to address the low conversion of certain products that you actually want. And so I think a strategy might be just, making that value proposition more relatable and more easy. And going back to, the community benefits plan and really teaming. That's something that we really, really focus on in the DOE, and was mentioned last time, where we don't know everything. We'd love to get more input on this, and we're continually trying to get better. But we have some mechanisms that I think are really important, and one of those is for our funding opportunities. We have teaming lists. And so, again, nothing new necessarily, but these are lists where you can put your name in and you can self-organize. And so this is how we get national labs partnered with, industry. This is how we get small schools that have, potential technology out into the world, and it can be commercialized. And so I think that's one strategy as well, of getting the people together in that communication piece.
No, I think Melissa and Thomas made really good comments. I would just add, maybe from a developer perspective, there's going to be a big difference between greenfield and brownfield on the way that somebody can think about CCUS. And in a space where there's a lot of new projects or new load being built, it's an opportunity to add CCUS as another part of the sort of site due diligence checklist of, can I get this permitted? Can I get it financed? Those are all the questions people have historically asked. And I think a new question is, how is this site on a scale of 1 to 10 from a CCUS applicability? Am I have to build a really long pipeline that'll never get approved, or could I actually sequester, that would be a 1, or could I actually sequester right here on site? Maybe you start selecting sites that are actually, they have the right geology, they're in favorable jurisdictions. For example, Wyoming has passed some really interesting laws to enable this and make it easier. North Dakota has a forced pooling concept for CO2 sequestration pore space, so that you don't have to get a lease from every single mineral owner in the unit, which could basically prevent most projects from happening. So some sites will end up being more attractive than others for CCUS. I think that'll be an interesting layer to see how that can come in. And then really the biggest barrier, if you could cross the permitting piece, is it is still economics. And for ethanol, for a brewery, something that produces 100% CO2, it's quite economic with 45Q to go capture that and sequester it if you could permit it. For post-combustion, where the CO2 concentration is maybe single-digit percentage CO2, you then have to put in an amine concentration process. That's a multi-$100 million piece of CapEx or more, depending on the size. And the 45Q payments, even for permanent sequestration, they don't really pay for that. And so I think it's going to require another layer of incentives, frankly, to make the post-combustion piece work. You can look to Canada they have a even more generous per ton sequestration payment than 45Q, and an investment tax credit that can fund 40 to 60% of the capital cost of the project. That works. So there's some gap between 45Q and the Canadian framework where the economics kind of tip over a threshold, and we just frankly don't have a good economic model for post-combustion capture and sequestration in the U.S. today, even with the updated 45Q, at least not in most of the projects that we've looked at. And we are really actively trying to develop a larger scale CCS project in association with a data center and a power plant as like a model, but it's hard to do it in the U.S. without sort of state or federal incentives.
Yeah, thank you. Thank you. Am I being told that it's time to move to audience questions?
If you have a question, please raise your hand so a WGA staff member can get a mic to you.
Scott Weiser, Denver Gazette. I'm wondering if you have any numbers on how much government data centers need by way of power.
I don't know, I don't have numbers off the top of my head, but the government share of the data center market is a really large share. I mean, if somebody told me it was somewhere between a quarter and a half, I wouldn't be surprised, just knowing what I know about the data centers around Virginia in particular, and around the DC area. There are a lot of very, very large power consuming data centers there. Most of them don't have a name on the building, and most of them are filled with agencies. You're not supposed to know who they are, but they seem to have a lot of computing power.
Yeah,
we got 2 over there.
Got a couple more questions.
Okay.
I was about to ask another one anyway.
Thank you so much, Nusha Jami from Lawrence Berkeley National Lab. I was wondering actually regarding the flaring and then using that as an energy source. What happens if the oil and gas production in a location you are working sort of reduces or changes in different ways? Are you like, is this something you can just pick up and take somewhere else? Like, have you thought about that?
Yeah, it's a great question. And a big part of our, one of the constraints in designing this technology was to make it modular and mobile, because you're exactly right. Oil wells do decline. They all decline towards zero over time. And as the reservoir pressure depletes, then the oil production rate and the associated gas rate is going to go down. And so we move systems all the time. We really have designed a system that does not require a cement foundation. And so we can actually pick the whole thing up with a crane, put it on a truck, and sort of send it down the road. And we've done really very large-scale mobilizations and demobilizations in a week, 2 weeks. Really big projects might take a little bit longer, but our teams have gotten well trained on doing that kind of thing, packing it up, moving it, and redeploying it. And then the challenge is just having another site contracted from a business development standpoint. So we work hard to not have gaps and not have idle equipment.
My name's Jim Hughes, and I specialize in development of new drilling technology for sequestration and geothermal. And my question is really for Angela. Why not sequester all emissions from an industrial facility and eliminate the carbon separation and capture expense?
Yeah, that's a great question. The way the Class 6 permitting is set up for EPA requirements or for states who have taken on primacy, and the understanding that we have of how we can safely and secure the material underground in a way that keeps it down there and we know won't have a negative impact on our groundwater, on the rocks where we're storing in the pore space, is that we need to remove all the extra pollutants or junk to be able to just pump CO2 alone underground.
Well, there's thousands of wells, disposal wells, around the world in basement granite, which is as deep as you can go. And a Class 1 permit allows you to pump anything down those wells. So when you're as far away from groundwater as you can get, it's kind of an ideal sequestration formation.
Right. I think the big thing here is we're looking at a different class of wells. So instead of those Class 1 wells, we're looking at Class 6 wells, where the idea is to take those CO2 molecules, store them underground in the pore spaces in a saline formation that will potentially eventually mineralize and become a secure portion of that pore space so that it stays underground. But it's a lot more difficult to track and monitor and ensure that it is remaining stable and remaining underground, especially thinking about just how much CO2 that we need to store underground, that we really need to maintain these strict requirements with the Class 6 wells so that we can ensure that we are looking at a permanent storage of that CO2 underground.
Just from a technical standpoint, the exhaust from a gas turbine is only about 5% CO2. So you've got 20 times the volume that you have to compress and put down. So the cost of compression and the energy use of compression would be prohibitive to basically try to sequester the entire gas stream.
I actually think that's a really cool idea, personally. There is also a reservoir constraint, though. In some reservoirs, there's just sort of a max volume that could be stored without creating so much pressure. You could actually have like activated faults, and I'm guessing that might be part of like a technical consideration for trying to put the entire exhaust stream downhole. But I mean, it's actually a really interesting idea.
Yeah, and it was another good point as well, not just thinking about that storage side, but thinking about the ability to capture it as well, right? And that was a major portion of what our study was looking at how you need to clean up that flue stream to be able to reliably capture and then sequester the CO2 as well.
Yeah, I mean, that's really important within the context of where we work. So IEDO really sits at that mid-TRL or technical readiness level. And so, kind of lab, bench scale, all the way up to pilot. And the way that we look at carbon, we have some sister agencies that look at sequestration and carbon capture. We're really looking at the utilization piece. And so, like, if you're just trying to get rid of CO2, putting it in the ground is great. We're really trying to look at it as a waste stream that we can now put into and make products with, right? I mean, we're, close to 90%, if not more, of all chemicals are produced from fossil fuels. And if we can replace that with some sort of other carbon source, which CO2, if we're going to be capturing it, spending the energy and the effort to capture it, we really want to be able to utilize it. And I think the gold standard here, and something that I think has been discussed, kind of within our organization and others, especially the national labs, is the idea of kind of skipping even the capture portion. If you can take a stream that's 10% CO2, do some sort of chemistry to create a product and skip that actual capture piece, then again, now we're putting carbon into a useful product. I mean, you do need to start thinking about a life cycle and how that product is used and how long it sequesters. That said, I mean, I think it's a really interesting opportunity that goes beyond just the capture as well as the sequestration. It's the U in CCUS is still there, I promise.
Yeah, maybe just one other thing that I'll add to that Tom brought up is we know how to capture CO2. We know how to transport it. We know how to store it. But also even thinking about the report that I highlighted at the start of this today is this isn't necessarily how everything will look exactly 10 years from now, right? We were looking at a 90% capture rate, but we know we can capture more. And right now we know how we need to transport it, how we need to store it, how much energy it's taking, but we also presume that we will get better at all of this with time, and that even say the amine solvent that we were looking at in our report, we'll probably find something better than that to be able to store or to capture our CO2 moving forward. And so I think looking at that technology readiness level of where we're at now, all of that we expect will continue to improve upon with time as well.
Can I try to wrap this up with a bow?
Yes.
It's like, yeah, please do. I'm going to answer a question that nobody asked me. So thank you. It's really interesting to kind of hear this range of perspectives across the table, and thinking about this, the title, right, the hard-to-abate. This is not a matter of a knowledge base at this point. It's actually a matter of doing what we have, for the most part, figured out how to do, right? We do know how to capture carbon. We do know how to transport it. We do know how to store it. We also know, just speaking about our industry, how to use alternative fuels. We don't actually have to fill up a kiln with coal and heat it up to the temperature of the surface of the sun, although that is what we've been doing to make our product for I don't know, a couple hundred years. So we know how to to decarbonize, the issues that we've been talking about here during this panel are really practical issues. So you brought up performance of the end product. We make low carbon products today that perform or outperform ordinary Portland cement, which is the industry standard. In many, if not most places, those products have to receive sort of a low carbon designation, or we can't sell them because the standard is a recipe-based performance standard. It's said to meet the performance standard if we followed a certain recipe to make the product. Even if the product outperforms that recipe, it's not a performance-based standard. That's a really practical issue, right? We need to transport liquefied CO2 over distances and put it in secure underground storage. But we have to build that pipeline, and communities have to be on board with that. And so I hope your takeaway for our panel is more about getting it done than really not knowing what to do. We do know what to do. It's just a matter of sort of organizing our incentives and the way that we have done business and the way that we have permitted infrastructure and kind of thought about development and adapting it to this age of decarbonizing, which is really where we are. So thanks.
Well, yeah, thank you so much, everyone. Great panel. It was a pleasure moderating everyone.
All right. At WGA's annual meeting in Boulder last year, Governor Polis and Governor Gordon signed a memorandum of understanding committing their states to work together to advance direct air capture solutions. Capitalizing on unique resources and assets of each state can help advance these technologies at a regional scale. Other approaches, such as DAC hubs, can help maximize community benefits and leverage local and regional expertise. Our final roundtable today will explore collaborative approaches to developing carbon removal, highlighting how Western states are in a unique position to advance this technology. To moderate this final session, it is my pleasure to welcome back Governor of Wyoming, the Honorable Mark Gordon.
Thank you, Abby, and thank you all for being here today. I think it's a mark of a successful conference when people are having side conversations, having a hard time coming back into a room and sitting down. And so really what these are intended to do is to spur that kind of conversation and get people thinking. And boy, I got to tell you, the last couple of panels that we've heard have got my mind thinking. And this panel actually will probably bring all of that to, I just admitted to them, I have no idea where we're going to go. But I think that's really a mark of how exciting this time is when you think about the problem that we've set out, carbon dioxide in the atmosphere, the solutions that we apparently have or in developing, the opportunity set that we can develop that with, and what are the constraints that we look at it. And so if my worry has been that we are so binary in how we look at these things that this panel probably can open up that conversation to talk about where are the cogeneration opportunities, where are the low-hanging fruits that can be picked that really just make sense. And so because these people are much wiser than I am now going to turn this over to Matt to elucidate you all.
I'll give it a shot. So, yeah, I'm Matt Fry. I'm a senior policy manager with the Great Plains Institute. I'll start off with our mission, and it's because we're kind of required to do this, but yeah, we're a small nonprofit organization based in Minneapolis, Minnesota. We're not as small as we used to be. Used to be 6 people, and now I think we're about 45 people. Our mission essentially is to work on things to decarbonize the economy through policy and technology. I do not live in Minneapolis. I actually live in Wyoming. I've been in Wyoming about 20 years. I worked for the state for 18 years, and I've been with GPI for about 2.5. I've got a history of working on natural resources, energy, and carbon management, and I still work on natural resources, energy, and carbon management. So at GPI, we tend to use analysis to help build out our initiatives, use a lot of information based on data just to kind of move forward our policy and our technology initiatives. I'm going to follow the model of using our analysis and using a lot of pictures to describe some opportunities to actually figure out how you may best develop relationships and where you may consider building out these carbon management projects, kind of in the sense of why we're here to talk about this particular panel. So the particular analysis I'll talk about is one that we did a few years ago on carbon and hydrogen hubs. We did this because the federal government provided about $12 billion in incentives to build out carbon and hydrogen hubs. So we used a series of geospatial data to figure out where they may make sense to build out. This first slide, like I mentioned, we use a lot of pictures at GPI to make things easily consumable. I would say this slide is not easily consumable, but what it essentially means is, there's opportunities to utilize the hub structure to build out projects that reduce capital requirements, improve environmental quality issues, and just kind of make the project build out in a more efficient way. So for the conversation today, we're talking about decarbonization. If you're doing that, you're looking at how to reduce your emission profile, make things less carbon intensive as they go out the stack. So if you're looking where to site a project, the first criteria you may look at is where your emission sources are. We tend to look at emission sources that qualify for the 45Q tax credit just because those are going to be the first movers. There's actually a cash incentive to capture that CO2 and to store it permanently in the ground. ground. And just so folks know, those circles there are where we're going to end up. So you can kind of keep that in the back of your mind as I move through this. Once you figure out where potential opportunities for capture are, the next thing that makes a lot of sense to look at is where your geologic formations are. I think no matter which analysis you look at, we're going to have to capture and store a lot of CO2 if we're going to meet our climate objectives, like in the millions and billions of tons of CO2. So if you can actually site your project, no matter whether it be, post-combustion, retrofits, DAC, or if you're looking at opportunities for fuel switching, no matter what you do, if you develop that project in a location that's close to amenable geology, you may save yourself some heartache because it's really hard to build pipelines right now. I included this slide just because we're talking about decarbonization. If you want to look at opportunities for, as I mentioned before, fuel switching, we look at where existing hydrogen and ammonia production are now. There's also some pretty low-hanging fruit for CO2 capture associated with these facilities. This is a busy slide, but I think it's pretty important. As the last panel talked about, low carbon. I hate zero carbon, so I'm going to say low carbon intensity electricity is pretty important as we develop these DAC and low carbon intensity projects. So that makes a pretty high, it's pretty important when folks are looking at opportunities and locations for siting. I'll talk now a little bit about linear infrastructure. So we've got a 2+ million miles of pipeline infrastructure across the country today. Natural gas, crude oil, CO2 pipelines. There's two ways to look at the opportunities to co-locate along with these existing pipelines. First is there's existing right-of-way. So what you see is there's already a disturbance on the landscape. So if you utilize that existing disturbance, you could potentially build out a project with a lesser environmental impact. On the other end of the spectrum, there's opportunities to use existing pipeline infrastructure, maybe for a low PSI CO2 transport or for a low concentration blending of hydrogen and natural gas pipelines. So another thing to consider when you're looking at opportunities to work together on things. I promise I'm getting close. And then the last couple of slides we'll look at is multimodal transportation. I don't think that multimodal makes a lot of sense from an economy of scale perspective when you're looking at CO2 transport or if you're looking at hydrogen transport. But when you're looking at opportunities to bring materials in to actually build these projects, it makes a lot of sense to consider these forms of transportation. So here we look at where the existing railroad distribution are, as well as the existing truck and barge locations. So those are the interstate highways. Not a lot of barge traffic here in the West, but in places where they do exist, they're pretty important. And as I said, those circles were where we came out on the long run. So we're sitting right in the center of an opportunity for a pretty good hub based on all of those physical criteria that we just described. So that's just kind of the opening I wanted to make today to kind of figure out how we may talk more about these opportunities for siting.
Okay, thank you. Maybe a shift to the discussion. That was very informative. Thank you, Matt. I'm Nusha Jami. I'm the Chief Development Officer for Research at Lawrence Berkeley National Lab, Earth and Environmental Sciences area. We are one of the Department of Energy's national labs, and our area, the Earth and Environmental Sciences area, have been working on carbon capture and sequestration and everything geosciences for many, many years. So we have a lot of expertise in-house. This specific project I want to talk to you about is the Direct Air Capture Hub that we got funded through the Department of Energy this past August. We won this. This is mostly feasibility study, so I'm going to just walk you through it because it's a little bit unique and different. And since we are talking about partnerships, I'm just going to touch on that. Let's see if this is going to move. Oh, here we go. Okay. I mean, we have already talked about this, but I wanted to just highlight the importance of it. We obviously decarbonizing the West, we require capturing carbon and removal at gigaton scale, and a lot of that needs to happen in addition to, we have to capture carbon in addition to transitioning to renewable energy and sort of reducing our emissions at the same time. And a lot of that, after being captured, what are we going to do with the gigaton of, okay. No worries. I can handle this. Okay. So when we capture it, then question is what we would do with it. We had a conversation this morning and in the previous panel about, we can obviously use that, use the CO2 in products and different material, or we can sequester it, which is another way of reducing it. Now, we have been talking to a lot of communities throughout the past year or two and trying to understand why people are concerned about decarbonization and different modes of decarbonization, especially direct air capture or carbon capture and sequestration, and trying to see if there are some scientific questions or inquiries that we need to actually do to make sure whatever we do ends up being done right and doesn't have a lot of unintended consequences. Then 50 years from now, we'll sit down and say, you remember we were talking about that thing? We should have thought about this. So obviously, technologically, we are quite advanced. We can do a lot of these things, but the question is where, how, and what are the different guardrails that we need to put in place to make sure it's done right. The question, obviously, the air quality is one of them. We had a conversation this morning, pipeline rupture and the potential cause of that or the health effects of that. A lot of discussions around groundwater. I know we are in a room full of people who are talking about potentially sequestering carbon, but remember, in the rooms that people talk about water, and I'm a water expert, so I tell you, like, we sit in a lot of rooms and we talk about how that fossil groundwater that's down, thousands and thousands of miles below ground can be used as a source. So we are double counting a lot of these things, and also the question of earthquake and potentially if the injection can cause earthquake. The Outdoor Air Capture Hub is unique because we actually started from the community piece of it. We were really interested to see if we bring communities in to the table, have a conversations with them, understand their concerns, can we actually build this feasibility study, not just around the technical concerns we all have, but also social concerns that exist. And in addition to that, the question of who's going to own all this infrastructure that comes in, how it's going to be operated, who's going to gather the data, who is responsible to make sure this data gathering and analysis is done right, and basically making sure that we are doing this in a right way. It's basically a connected hub. We have a number of DAC companies that are working with us on this proposal. We have solar companies, heat company. We have a carbon mineralization unit that's going to work with us. I'm going to talk about all these partnerships. But the most important thing is everybody who's involved in this project knew this is going to be a community-focused effort, knew that they are going to be, we will need to have community support if this project gets done, and they still stayed and wanted to see how we can move this forward. The project basically will have we're going to establish a community oversight council that's going to oversee some of the decision-making process criteria that are used in life cycle analysis or their environmental impact. We are going to look, as I said, into the ownership model. What kind of business model do we need? What are the revenue pathways? Who needs to own what? What kind of public-private partnerships need to be put in place to make sure this done right? And also, if the jobs are created, who's going to benefit from those jobs? Are these going to be jobs that the local community can get involved in? Can we train them to make sure they can actually have a job in the air capture companies or other startups that are coming to the local community? Or is it going to be mostly construction jobs? So, sustainable good jobs and skilled workforce was very important, and it's more important for communities as well. just to show you how this is going to work, we have a team that's working on the technical side of this, the direct air capture piece of it, potential sequestration, and how all these pieces are going to connect to each other, and what kind of energy source we are going to use. And we have another team of community experts that are telling us what their questions are, what do we need to consider, what are the value systems they want us to incorporate, and also ownership, permitting, and all those pieces. And these two are not going to happen in vacuum. They're not, while they're happening in parallel, they constantly talk to one another. So whatever we do in the community piece is going to inform the technical analysis, and whatever we do in the technical analysis will have a feedback loop to the community. And the oversight committee would be part of the kind of trying to kind of build this vision and making sure we have the right monitoring, reporting, and verification set up, and what kind of transparency we need to put in place. This is a feasibility study, so we're not going to build a DAC up now, but by the end of this, if we have done this right, we'll have a very, hopefully, a community-driven and community-informed project that then can go into the design phase, and potentially we can build it. Just the last slide, these are the groups that are involved in this project. We, the Lawrence Berkeley Lab, and Berkeley Law, UC Berkeley is leading this effort. The Center for Law, Energy, and the Environment at UC Berkeley is a co-lead. They're basically leading, we are the co-lead. And then, as I said, we have a few companies that are helping us for the analysis, design, environmental impact. We have community groups, and also we have technology providers, a broad range of them that are working with us. And with that, I am going to hand it off to Ken.
Thank you very much. Can you guys hear me? Perfect. Okay, there it is. So just very quickly, wanted to, by the way, it'll feel like a bit of a change of pace. I'm here to talk a little bit, kind of be the DAC voice on the panel this afternoon. I've heard a lot about DAC so far today. I'm going to hopefully bring a little bit of a different perspective, although a lot of my talking points, quite honestly, have been taken already, but just keep that in mind. I wanted to start with a little bit of an introduction of myself, obviously, but also of who Global Thermostat is. So I've just recently joined Global Thermostat, just really in the last 6 months, so I'm really on the steep part of the learning curve in terms of the CCS industry and DAC in particular. I spent the first 20 plus years of my career with a company called Air Liquide, so industrial gases company focused on gas separation technology. Essentially, spent a lot of time commercializing different aspects of what we do, or what we did, as I should say, in Air Liquide, both greenfield, brownfield type projects, working with a lot of different stakeholders, obviously collaborating with a lot of partners, building multi-million-dollar projects. So fits very well with kind of the mission, if you will, that I have at Global Thermostat, and the mission that we, I think, have collectively in terms of bringing DAC forward and really kind of building that industry that we've been talking about. I'll kind of segue over to a little bit of a presentation about Global Thermostat. So I'll start from the beginning. I'll try and move through it rather quickly. So we were one of the first, I say one of the early entrants into the DAC industry, or into the DAC space, right? Founded in 2010, really focused on the chemistry. We use also a temperature vacuum swing adsorption system, focused on solid sorbents and contactors. I'd say our business model and perhaps our configuration is a little bit different than what we've talked about earlier today, and we'll talk through that a little bit. But in general, focus really on the chemistry. We have a number of pilot plants, R&D efforts. We've participated in a number of DOE projects. In fact, one that will be shipping out to Hawaii soon to feed CO2 to algae plants, or to algae ponds, I should say. So again, lots of different applications out there for what we do, right? Nice, a lot of intellectual property, protected with a nice patent portfolio. We don't rest on our laurels. We're always continuing to try and drive, we've talked a lot about material science and amine sorbent chemistry. We're always focused on trying to drive all of those things forward, right, for the betterment of the industry overall. I'll speak quickly about the 5 key drivers of DAC. Again, we've talked a lot about DAC today, so I don't want to spend a ton of time on it, but I'll speak more from a Global Thermostat perspective in terms of how we manage these components. So as we've talked about, CO2 is very dilute in air, right? 421 parts per million. we have to move a lot of air to get any real recovery of any significant volume of CO2, right? So at Global Thermostat, the way we handle that is again, a air movement system using large, proven industrial high-efficiency fans, pretty much what you would see in a cooling tower or in any industrial facility anywhere in the world. And we move that air through ultra high surface area contactors. We use kind of a unique sorbent chemistry, a amine-based chemistry to capture that CO2 selectively into the contactors as that air passes through. And then we move that into a regeneration phase, if you will. So to desorb the CO2 from those contactor panels where it's collected, sent downstream to either sequestration or utilization application. So there's lots of different ways we can do that. What we kind of pride ourselves on is kind of the physical embodiment of what we've built, right? So it's not just the contactors, the chemistry. It's really the way that we've put this moving absorbent bed system together to really make the capital efficient system that DAC needs to be low cost and scalable, right? We optimize energy. The regeneration is low temperature steam. It's not a high temperature. We can utilize a lot of waste heat in different industrial systems to generate that steam and that temperature needed to free that CO2 for use, right? So again, those are just some elements, but at the end of the day, ultimately what we're trying to create and what we need to drive this industry forward is an inherently scalable platform, right? So we have a couple of different embodiments that we've created. One's our T-Series, more of a tonnage, 10 tons per year nominally type system, like the one going to Hawaii that I mentioned. The K-Series, which is more 1,000 tons per year. The picture that you see on the screen is actually a system that we have operational right now. Over the last year, we had a ribbon cutting on it last year. Governor Polis joined us for that ceremony, along with a lot of other dignitaries in industry and academics. And then we have this M-Series, which is more megaton, gigaton scale. It's really the industrial climate scale solution that we're all driving towards. Each one of these shares the same contactor basic, the same sorbent chemistry and everything else. So that science, if you will, translates very easily from one phase to the next. And again, ultimately, where we're driving toward are these large, megaton, gigaton type installations, and that's what we've been talking a lot about here today, and probably going to be the premise of most of our discussion in this panel. We see the commercial tipping point for DAC being sooner than later, right? More 1 to 2 or 2 to 3 years versus 10 years plus, which is again, there's a lot of differing thoughts on that. Our business model is an original equipment manufacturer. We want to supply the best DAC technology into the marketplace, into that decarbonization ecosystem. We want to be a part of the value chain. We're not going to necessarily be the one to own and operate a system or work with the CDR credits or really be involved in that way. We'll work with sequestration partners and owner operators and developers, but at the end of the day, we want to be the best provider of DAC technology into the marketplace, which is really what happened in the solar industry back in the kind of early 2000s in terms of finding the best technology, promoting it, and then moving the industry forward. And that's what we want to replicate here. This is our leadership team. Paul Nahi joined us about a year ago as our CEO. He comes from the solar industry, so maybe it's not a surprise that we're trying to kind of capture that same approach within the DAC industry. And I'll close on this slide. This is a facility that we have operational here just outside of Denver. The one that I mentioned earlier, the one where we have our 1,000 ton per year unit operating for about the last year or so. More than happy to welcome folks that want to come out and take a look at it, kick the tires on our technology, talk to our team. But within a 2-acre facility, we're able to take microgram all the way up to kiloton technology and test it and rapidly move it through that progression to get it to the market. So again, that's what we're all about trying to do, and I'll stop it there so we can get to the rest of the panel.
Well, thank you, Kevin. That's really the first picture I've ever seen of Governor Polis with a tie on, so I have to say that's wonderful to see, and how you got him there is amazing. I think what we've described here is really an interesting framework, and I want to just kind of explore a little bit how collaborative initiatives can impact technological innovation and how can that be deployed within Western states, and what the policy framework that really could help facilitate that kind of work? Governor Polis and I signed an agreement, and we've also worked between Utah and New Mexico, Colorado, and Wyoming on a hydrogen hub. These are initial steps. And I guess I'm trying to figure out how we can make that open up more. So pretty much anyone who wants to do it. Nusha, do you want to?
Sure. Look, I think we talked about this earlier too. This is not a technological problem. Obviously, we can improve our technologies and do more. But it is definitely a regulatory and policy need or gap that exists that we need to do. You need to sort of put it together before we start having a successful industry. And also a safe industry, right? Because right now, communities, obviously, when you talk to them, they sort of, you can tell them this is the technology, this is what it does. They can ask you questions, but they don't know who's in charge, who makes sure that you gather the right data, you have the right guardrails in place. You actually earlier mentioned about underground storage. Who owns the underground storage? How do you manage this pore space? What are the different criteria we need to put in place to make sure if people start sequestering, we don't put too much pressure? I mean, we, again, have the knowledge. We just need to make sure there are boundaries set to make sure this is done right. And I think definitely policy and governance innovation, it needs to move hand in hand as we are deploying these technologies. And I think that's when then you start having more financial security maybe come, or money flowing in, because there is a little bit more confidence in, okay, we know the technology, there are policies, and now we can put our money into this and get the right outcome we want. So I think, again, one last thing I would say also, we also need to be much more transparent. I think this is a new technology. Now we can do all sort of data gathering, right? So we have all sort of technologies that can gather data at every part of this process. And we actually have to make sure we leverage those and take advantage of them to make sure we have the good monitoring, reporting, and verification system set up that's transparent and makes sure people and can create confidence in the process. So.
Thank you, Nusha. Matt?
Yeah, I would just add that like the policy challenges, those are things that you can't model. So when you look at the slides that I presented and the pictures that I presented, those are the physical criteria. So that's kind of where you start when you look at these to begin these collaborations. But the policy, in my opinion, probably because I'm a policy wonk, but the policy is really where the rubber hits the road. So when you look at, for instance, the MOU between Wyoming and Colorado, Wyoming is just honestly ahead a bit in the policy game. We have a legal framework in place that allows for storage of carbon. We have Class 6 primacy, all things that Colorado aspires to and is moving towards. They're just not there yet. So I guess the collaboration between the two states makes a lot of sense because one state can utilize the strengths of the other, and conversely, I mean, Colorado has a lot more emission sources than we have in Wyoming, so we can help facilitate some of those challenges for Colorado. So I think the policy perspectives, those legislative frameworks, that's where you really need to dig deep and figure out who your neighbors are and how you can help one another to build out these projects in a more efficient and effective manner.
Excellent.
Oh, sorry.
Go ahead.
Okay. I was going to say, I'll weigh in on it as well, but not so much from a policy perspective. I think as the resident sales guy on the panel here, I'll probably speak about it from a different perspective. No, I think in terms of, regional collaboration and ways that, we can kind of work together to drive things forward, right? I think what regional bodies are really good at in terms of being able to do is, kind of swarm internal resources together, right? There's just a lot more available, especially if you talk about cross-state collaboration and having a bigger group of talent to draw on, right? Just to create those support teams, also able to attract external resources as well in terms of talent, in terms of commercial interest, and really kind of physical resources that might be available. Sharing best practices across teams in terms of what's worked, what hasn't worked, what are we doing over here that's different than maybe how you guys would approach it from a different perspective, or having different resources available. Again, in developing policies, incentives, grants, tax credits, those are all things that I think, again, we've talked a lot about DAC, especially being in kind of a nascent space in terms of an industry, and those are the things that can help. I say it all the time, but kind of help get that flywheel, that business flywheel spinning, because once it starts to spin and once it starts to get its own momentum, it can move forward on its own, right? It just needs the structure, probably needs some of the support to make that happen in the early days of what we're doing. And I think if we look at collaborating across states, I think there's just a lot of resources that could be pulled together to make that happen.
Yeah, and it is interesting to me as I think about it. I don't want to take us off too far, but that policy framework is so important. We have a multi-state agreement on rate setting and the challenges, and of course, some of us in the West rankle at California's leadership on some of these issues. Maury brought up Wyoming's leadership, which was to say that we have a number of coal plants that are reaching near end of life. They're being depreciated. We have a lot of renewables that are coming online. They cost money. That requires a lot of grid infrastructure that we don't usually put into the cost of what that development. We talk about it as clean energy, but without all the attendant costs that come there. And so really thinking about all of this in terms of marginal cost is something that I wish that PUCs could do a little bit more, because PSCs, in our case PUCs, generally think about how do we tamp down rate increases for the points Patricia made. Nobody wants to spend more money, but they also want to see regular power. They want to be confident about that. And yet all of these things come with a cost. And somehow in that national narrative, we don't talk about that. We talk about clean energy versus dirty energy, and it's almost this binary notion. And I think if we're going to move forward, we're going to have to build that framework across states. Sorry to do that to you, Matt, but here we go.
Well, I'll just say I agree 100%. I think the answer's magic. I don't know that we've come up with that, but I mean, honestly, there is no great answer, particularly when we start looking at social pushback and real challenges associated with personal beliefs, and people get emotional about these sorts of things. So, I mean, those are costs that we have to consider as well as we dig into this sort of thing. I think honestly, let me say this. I think we're not having honest conversations broadly about how to decarbonize, just because the things that you mentioned now, they're really hard. People have niches of their favorite technology and their favorite policies. So just blatantly honest, I think that these are things that need to be discussed more up front and more honestly, because we have a lot of work to do and a lot of projects to build. And until we get beyond these conversations and these non-conversations, we're going to really struggle to meet your climate objectives, Colorado's climate objectives, and the national climate objectives.
And Kevin, because Nusha was writing lots of things down, I'm going to turn to you. That way she can...
Sure. Yeah, so she can keep writing. I think it's important if we break it into kind of near-term and long-term focus, right? I think we've all talked about, again, and I'm speaking from a DAC perspective, DAC projects are, with life expectancies, just like any industrial facility is, 20, 25, 30 years or whatever that might be. Again, with continued improvement as we move forward in terms of technology. So I think it's important that we put the near-term policies and regulations in place that help spur the industry forward, but we also keep in mind that these are long-term investments. They need incentives that reflect that, because again, if we have support short-term that carries an investment horizon out to 10, 15 years, well, that's great, but people are making investments on a much longer term basis, and so they need that, again, that security, that risk mitigation that comes with, having a little bit of a little bit more support, at least, again, short term, while we get this industry kind of off the ground. And I think that's an important piece of it.
Okay, I was writing things down. I think a couple of things I want to say. One is, decarbonization pathways can be very different from location to location, right? Each one of our states has resources that we can rely on, and is short in other things that we would love to have but don't have. I think decarbonization portfolio for California might look very different from Wyoming, and Wyoming's may look very different from Colorado. And I think we should acknowledge that we don't need to kind of homogenize this across the board, and we all don't need to do the same exact thing. So making sure we have national policies that incentivizes that diversity of approaches is quite important. That is one thing I wanted to touch on. The second thing is, I think you and I had this conversation a little bit outside. I think we have a chance to do a lot of things again at this point in time. And some of that means that we can take advantage of the synergies that exist across the board rather than creating more linear systems. Then in 50 years from now, they're going to fall apart and we have to do it again. Linear systems are very resource intensive, and they're not very efficient. We have this conversation a little bit like in a second panel about how somebody's waste can be somebody else's resource. And we should actually focus on that a little bit more when we are talking about DAC or other renewable, other decarbonization pathways or other carbon capture solutions that exist. For example, I'll give you an example. There is a DAC hub we are working with as part of our portfolio that Capture 6, that they actually use wastewater as their solvent to capture carbon, and the water gets treated along the way as they capture carbon. I think that's like fantastic in many ways because you are kind of like taking somebody's waste, turning it into a resource, and also generating resource after that. So focusing on policies that can incentivize synergies, I think it's extremely important as part of this as we decarbonize. Now, that goes then down to the conversation, the point you brought up, Governor, about infrastructure investment and the rates. The more we, again, going back to synergies and portfolios, the more we focus on synergies, the cost of infrastructure comes down, the revenue streams are going to be diversified a lot more. We will have more opportunities to do multiple things rather than one single thing. And we certainly, in this time and age we are living, we need to kind of focus on multi-benefit solutions rather than singular benefit solutions. So, the last thing I would say is going back to that portfolio strategy. I think we need to remember decarbonization pathways are not going to be all technological. We need to have a portfolio of nature-based solution and technological solutions all together. We can't put direct air capture in every street corner, right? We have a lot of carbon to capture. So the strategy needs to be multidimensional. So just those are some of the thoughts on this.
Yeah, well, there's quite a few. I want to open this up to the audience, if that's okay. I've got plenty of questions here, but I'm hoping this has spurred a little bit of thought process. And so if there are questions, now would be a great time. If not, I'll go back to my list of questions. I'm not a college professor, but I know how to. Well, great. I think one of the big challenges with regional efforts is, who's the consumer, who's the producer, and how do you balance that in a policy framework? How do you socialize the cost of things that you need to do, and how do we value carbon itself? We have imputed costs that come about, Southern California, for example, with their floods, and it's attributed to climate change and the potential for that, and certainly attributable enough that we see insurance companies unwilling to insure in places like California and insure in places like Florida because of the potentials of that. That started a few years ago when Lloyd's of London said, this is now going to be an issue. That is a cost to consumers. How do we, because I think most consumers say, well, we just need to get rid of carbon. We can do this, but I don't want to pay for it. And so I guess the question that I have really is in that entire policy framework. How do we socialize the cost of carbon? Normally people will say, well, let's do a tax. But taxes are administration by administration. They don't necessarily work. You've seen that in Australia and other places. But if this is something that is going to come forward and is going to be able to support TAC, support carbon capture generally, and support all the kinds of chemistry that need to go in how do we take a carbon waste stream and turn it into useful products, that's going to take investment. So I always do this to my panels, and I apologize. You were all prepared for other questions. But Kevin.
Sure. Let me take a swing at it. No, I think it's a good point. I mean, socializing the cost of carbon capture and the cost of what we all kind of agree needs to happen going forward, and it's a challenging aspect, right? And there's no clear-cut answer. We've all talked about kind of social engagement and kind of socializing, if you will, the message. I think generally speaking, most people will say yes, this needs to happen, as you mentioned. But again, it's I think one of the prior panels was no one wants to pay more for XYZ, for power or whatever it might be, just to ensure that they have, to say that they're now supporting a cleaner, greener type approach to the environment or climate long term. Some will, not all. So in that framework, I think it's obviously it's about the education, it's the outreach, and it's kind of socializing it, more broadly than just say, these kinds of conversations are great, but to really push that out to the broader kind of consumer, if you will, and ensuring they understand the basis for everything that we're talking about and why it's important. But it also goes back, you mentioned consumer versus producer. Kind of goes back, at least in my mind, to, if I think of it from a project perspective, and I know that's kind of bringing it down a little bit more, a little bit to a tighter discussion topic, but, how do we model these types of projects, right? How do we model the cost of carbon, the voluntary offtakes? That market continues to evolve. The price of the technology in terms of what it costs to capture a ton of carbon, it's critically important, but that continues to evolve. So all of these things are dynamic, and they will continue to be dynamic for a long time to come. But again, what we're asking people to pay today may be different than what we're asking them to pay 10 years down the road, 20 years down the road. So I think it's an evolving message, but again, I think it's one that needs to get out to, again, a broader audience, and it needs to be repeated. It needs to be a conversation that continues to happen. So I'll leave it there.
Very good. Nusha, anything? Yeah.
Didn't write as long as the list this time. I think, Ken is right. I think education is a very important part of this. I think incorporating communities as part of this transition process is going to be super important. When people are more involved, they're more willing to pay. If something is out of mind, out of sight, it's harder to kind of justify. People don't think about it. They don't know what it takes. So it's very hard for them to value it. I think more and more the insurance issue is a huge issue for us in California. More and more that's, socializing that to people, like how, and the fact that people are struggling to get insurances, or actually the cost of insurance has gone up so high that it's very difficult for them to pay for it, makes them to think about the sources of carbon. Like how can we actually, it's not just capturing carbon, how can we reduce our carbon footprint in other ways? So I think we need to tackle this both at the source and at the, the capture, sort of the different capture technologies that can come in place. One thing I want to say also, I think you touched on something very important, which is who's a producer, who's a consumer. Maybe I think about this a little bit at state to state. We definitely don't want to end up cleaning one state, polluting another one. We just want to make sure the policies that we are putting is protecting everybody at the same time. And at the same time, people are paying for it and also feel, okay, if, I don't think, for example, one state should pay and then their carbon ends up in somebody else's backyard. So how can we make sure this is done right and this doesn't end up costing too much for some of the communities is also quite important. So it's kind of like the cost of unintended consequences that we are not capturing right now.
Thank you. Matt?
Yeah, I'll just add quickly. I think the easy answer from a policy perspective is a tax, right? Everybody knows the easy answer is a carbon tax. It's just, and even some industry folks are saying that's the way to go, but it's just not politically palatable, and it's not going to happen likely in the near term, if ever. So we need to figure out a way to make this a market. Glenn and I had these conversations years ago. I think Wyoming was kind of on the forefront. You know, we'll build it. You bring your stuff here. We'll charge you to store it here. With that sort of model, like, I think states have a real opportunity to show that sort of leadership. What happened under Glenn's leadership, honestly, was we had that mentality. The market kind of developed itself, and now we have a market that's sort of starting to establish, and hopefully we're going to build some projects. I think there's ways that other states can follow that model and develop a market, but without the backdrop of a tax, we're going to figure out how to make a market and make some money out of this to actually make it develop.
Well, and I would agree with you. I think that's terrific. So, you know, a couple of last questions. One is we really talk about the West being a leader in sort of promoting this technology. Kevin, with Global Thermostat, really a manufacturer of equipment. To make a dent globally, you know, the West of our nation can make a small contribution. But one of the biggest challenges is what you're going to see overseas. Mm-hmm. You've got countries that are developing now. You've got countries that are pretty well developed. And as a friend of mine says, poverty has never been a good thing for the environment generally. So the challenge, it seems to me, is how we engineer the technology, how we build the policy framework, and how we can then export that to the other parts of the world. Not to go off on a wild tangent, but I just do this on a regular basis. You know, it really does feel to me like the things that we can do here can be incredibly valuable to our local economy, but very worthwhile to the global environment. Mm-hmm. And so again, Kevin, just because that's sort of your bailiwick, let me turn that over to you.
So just very quickly, maybe just to provide a little bit of perspective, and I'm sure the folks from Heirloom and Carbon Engineering would echo this. You know, if I look at, and again, I've only been on board for, you know, and in this industry really for a short time, relatively speaking, but just what I've seen in growth over the last, let's say 6 months, and what we've seen, I guess, collectively over the last, 5 to 10 years has been tremendous in terms of just, again, a growing momentum in this space. If I look at kind of our sales pipeline, our opportunity pipeline as we sit right here, you know, a lot of it is in North America, a lot of it in the U.S., Western states. So we have MOUs, we have projects developing, we have lots of good conversations happening on all fronts. But we also have opportunities that are developing in other countries. You know, it's Spain, it's Denmark, it's Norway, it's Australia, it's New Zealand, and you know, Asia, and you just kind of go down the list. So there's worldwide a lot of interest and a lot of momentum again in what we're doing here in this space. You know, the West, let's say the West will end up probably, not necessarily the Western U.S., but the West, if you will end up probably being the leader in this space for the foreseeable future. But there are a lot of others that are very engaged and want to, are very hungry to pull this technology into their countries, into their industries, and really start to stand this up more and more going forward. And I'm excited to be a part of it. I think there's a lot of runway ahead of us in terms of what we're doing and what we're building.
So being a bit shameless in the proposal here, J.P. Morgan has recently put a lot of money into carbon, and it mostly is in Norway. Same with Microsoft, and so the opportunity set really is here if anybody's listening, and appreciate that, Google being here as well. And I do want to put a shout out to Project Bison. I think this is exactly the sort of opportunity set that can, you're really talking about direct air capture in Sweetwater County. And it is adjacent to an airport. It's a small airport, but sustainable aviation fuel is a piece of that. Cogeneration is an opportunity for all kinds of other industries to come along. Simplot is nearby. And so I think, finding those kinds of pieces, the private-public partnership really can make a big difference. And Matt, I know this is an area that you've kind of looked at when you were kind of working with Glenn. I didn't know if you wanted to expound a little bit on those kinds of opportunities.
I think there's incredible opportunity when you look honestly at what we've done with the ITC and other things. Those are tremendous. They're 100% public-private partnerships, and without those public dollars and those public incentives, I think we're going to struggle to get a lot of these off the ground, thus with the infrastructure law as well as the IRA. So I'm clearly not an expert in public-private partnerships, but I don't think that we're going to be a whole lot of headwind in this space unless we utilize them to their fullest capacity. And I would suggest these folks probably know more about it than I do.
Well, and I was going to let Nusha put a bow on everything.
I think we are definitely looking into public-private partnership as part of that direct air capture hub that we are putting together. And I think it's just, we do definitely need public money, but we also need to figure out how these technologies are deployed and where do they fit into the process, and who owns the technology, who operates it, and do you hand it off to someone, or do you stay on, in place and operate it? So I think a lot of that needs to be put together. I think, we are, for example, we are looking into, for our own little project, looking into some form of a municipal utility, or not a municipal, it's like a kind of some form of a utility that can be the manager of the different flows of carbon, but doesn't necessarily need to own the carbon capture process or any of that. So that's one thing. One last thing I want to say on also, you touched on emerging markets, and I want to say, again, going back to my earlier comment, opportunity areas for each one of these markets are very different. We are much more developed, so a lot of these technologies need to have a place here for us to, I mean, as Ken mentioned, the West probably going to run this because we're fully developed, and we have to come up with a way to capture carbon and do other things that we can to minimize the effect we already has had. But the emerging markets actually have a chance to do things very differently. They can actually build cities that are much more carbon neutral, or can generate a lot less carbon, or have a less carbon footprint, or they can actually think about modular solutions that can put in place to do multiple things. So again, I want to make sure, I want to encourage everybody to think a little bit more about how we can come up with ways to come up with optimal portfolios for every location we are looking at, because that's the only way we can do this right. Otherwise, we can sort of repeat a lot of the disadvantages that we have had in the past round of infrastructure building in this round.
Thank you. Well, let's give a hand to the panelists. And my apologies for taking you off on wild chases. Jack.
Thank you, Governor. Can you guys hear me now? Got it. I'm tasked with a few housekeeping items, but before we go, I want to thank, obviously, our last panelists here, but all of our panelists for contributing to just a thoughtful and meaningful discussion on this issue. It's a critical issue for WGA, obviously, as embodied by Governor Gordon's initiative. So just can't thank everybody enough for providing that insight, and which will certainly help shape our policy recommendations that we'll put forward in the report due out later this summer. So I also want to thank Governor Polis for hosting us this week, and obviously Governor Gordon for joining us today. I'll go a little off script too, because you opened the door for that. But Governor Gordon truly does embody the WGA spirit and the leadership and stewardship of the West that we, quite frankly, as an organization, wouldn't be able to survive without his leadership and that of his fellow governors. But I think it's emblematic that he's here. Make the time to travel down I-25, to come down, and I think as well as join us in Boise and just to host us up in Gillette. This has been an initiative that he put a lot of thought and energy into, no pun intended, but certainly means a lot to him. And so we appreciate just his stewardship and his leadership in holding and convening this discussion. So thank you for that, Governor. And, thank you. it's not always fun to be put on the spot, is it? Yeah, no, it's not. So, no, but really just want to thank all of our initiative sponsors and partners for helping making today possible. And then back to the housekeeping items, too. I want to invite everybody to the reception that will be starting just right out the doors here momentarily. Tomorrow, for those that are joining us, breakfast will be here at 8 a.m., and then we'll kick off our first panel and discussion at 9 a.m. So looking forward to seeing everybody. But really just want to thank, again, our participants and you, the audience, those that are here in person as well as virtually. Just we couldn't be here without you, and appreciate your support for the initiative, but also our Western governors and across the West. So with that, looking forward to seeing everybody out there. So thanks again.